Welcome to day 4 of Driving Mobility 7, where we're going to talk about vehicles in their connected world. Sustain Southern California, just in brief, is a nonprofit trade association focused on economic growth of clean technology and the integration of sustainability initiatives throughout Southern California. And to be quite honest, now we've actually broadened out beyond those boundaries, and we're working up in the Northern California area and in some other states. We have been working on in the mobility space, most specifically now for 7 years, as indicative of our title here, Driving Mobility 7, when we initially won a mandate in conjunction with the LA Economic Development Corporation and Lacey for what was then called the California Advanced Transportation Center, which we became one of. So when that mandate ended, we just continued, and we've only been growing bigger and bigger in the mobility space since that time. So it is a very exciting space, and we love being a part of it. In addition to these events that we put on publicly, we also hold internal working groups on mobility in various different areas. And those various different areas really focus in on the 4 major themes that we had throughout Driving Mobility 7. Theme 1 was drivers, influencers in mobility, what's impelling us forward with financials, investment dollars, technology, policy, legislation, et cetera, what's pushing this whole industry forward. Day 2 is a focus on OEMs. What are they doing? What are their trends? What are they integrating into their platforms? What do their futures look like? Day 3 was infrastructure, and it was quite for those of you who attended yesterday know that it was a quite impacted day. We covered a lot of ground and didn't cover a lot more that we probably wanted to get to. So here we are on day 4, and we're looking at connectivity, which is a fascinating, very rapidly growing space. We've brought together 5 speakers today, 5.5 maybe, speakers who know all about mobility and connectivity. So we're very pleased now to bring together this group to present to you. I'll remind you as we kick off that this is being videoed and that you have a Q&A feature there on your Zoom that you can click and write a question to us at any time during the course of this 2-hour period. So before we kick it off, I want to also thank our sponsors for this entire 4-day event, Angie, Black & Beach, and Lacey, LA Clean Tech Incubator. Thank you very much for your participation and your support. Otherwise, we wouldn't be able to do these kinds of things. So with that, I would like to introduce you to your session host and a now new good friend of mine, Trip Borstel, who's with NG. And I'm going to read Trip's bio, and then I'm going to hand it off to him to introduce our first speaker and lead us through the course of the 2-hour period. So Trip has a 15-year career as a strategy consultant to senior executives on issues of climate, energy, and resiliency. His passion is for the variety of ways organizations can accelerate strategy implementation. It generally involves a mixture of executive alignment, stakeholder engagement, and leadership habits to unlock the full potential of a system to achieve its vision for good. Prior to joining NG Impact in 2019, Trip worked in PwC's Sustainability Business Solutions practice, the Katzenbach Center for Organizational Culture and Leadership, and at Blue Sky Sustainability Consulting. In these roles, he was responsible for leading of engagement teams serving a range of clients in technology, healthcare, NGOs, and local government. Recent clients include Kaiser Permanente, VMware, and Los Angeles Clean Tech Incubator. Recently, he supported the city of San Jose in creating Climate Smart San Jose, a climate action plan framed around how sustainability can enhance the good life. He lives in Oakland. Well, maybe that's TMI for you there. We'll stop there. It does kind of go on and on. Trip is a very impressive background. We're very thankful to have you with us today, and thank you. Please remember to unmute. There you are. Thank you very much for joining us, and I'll let you take it from here. Thank you, Trip.
Thanks, Scott. I definitely should shorten my bio next time for the sake of brevity. Thank you, and thank you for hosting the seminar. I think we've got a really exciting session. Had a chance over the course of the last couple of weeks to chat with our panelists, and I think for NG, as we think about mobility, NG touches energy in just about every domain of life, including mobility. And so we globally have been doing a lot of work around all aspects of mobility, from thinking about strategy all the way through design, engineering, to the implementation of the infrastructure to support electrification and decarbonization of mobility. So I think we're going to touch on, some pretty fascinating aspects of it, and really framed around this, theme around, that the future of vehicles really depends on these decisions and structures that we build today. And so in the course of this panel, I think my colleague Steve Kelly, who will introduce in a moment, will start framing up kind of the major pillars of what it takes in order to help cities and companies make the design decisions today in order to be able to prepare them for tomorrow. And so, over the course of this panel, we'll touch on about the technology itself. Also, having those systems powered by renewable energy, making sure they're enabled by smart technologies and good sound policy frameworks, and then also, that they first and foremost look to create value for society as well as for the companies and cities that invest in them. So with that, I'm going to introduce my colleague, Steve Kelly. So Steve leads our mobility segment in North America. He brings about 25 years of experience in this area in renewable energy and in the high-tech sectors. In this current role, he helps transit companies, schools, which he'll talk about today, ports and airports really make that transition to zero-emission vehicles. He's the co-founder of Green Charge, which was acquired by Engie in 2014. Where he helped install battery storage systems in over 150 California schools. And I think for today, I think Steve, will bring in a very interesting case study of actually work that is in progress, where you can begin to see how the technologies that have taken and the decisions that are made today and the considerations in designing these systems for a school system to transition to electric bus. And so Steve, I will hand it off to you.
Thank you, Trip, and welcome everyone. This is such an exciting topic for me. I was fortunate enough to get involved in the solar industry for commercial and utility about 15 years ago and saw that market grow and expand to what it is today. And about 8 years ago, I got involved in the battery storage industry and really the ecosystem required for commercial and utility battery storage. And it's interesting to look back on those two markets and see the explosion they've had over the last decade and a half. And now I look at what that expansion is going to be for mobility and for zero emission ecosystem that has to be developed to make this successful. And I have to say, it's probably 2 to 3 times more complicated than those two industries that I've worked in the past combined, because there's so many different players that need to get involved to make this work. And it is a transition that is happening today. And one of the things that I kind of wanted to talk about is to share what we've seen as some critical foundations that have to occur to make this a smooth and successful transition. So if you go to the next slide, we've kind of looked at this in 5 different pillars. Is a zero emission fleet has to have intelligence, and it's not just the vehicle. It is what the vehicle's to connect it to, what is, whether that is efficient charging, renewable energy, building management systems, even in route and traffic information. And so these fleets are becoming smarter and smarter, and we're able to leverage that data to really improve the efficiency and operation and cost structure of developing an effective zero emission fleet. So I'll go into more detail of each one of these, but just to give you a high level view, I think intelligence is a key component of that pillar. Also is renewable energy. As we move away from fossil fuels and we're starting to have more distributed energy throughout the country, the question really is, how do I put localized energy that allows me to power our fleets, but also provide resiliency and other value and other benefits? So I do see renewable energy as a key component to building an effective zero emission fleet. Some of the other key things that we see is sound policy. We need legislators, we need state and local and federal leaders to really come up with a key effective policy that will drive the behaviors of converting this fleet. And I think another key component is the zero emission fleet has to create value. And there's quite a bit of ways to do that, which I'll talk about, because it's not just get in the car and drive it. It's what this intelligent fleet can now do to help not only lower cost within that facility, but also benefit the grid and have other benefits from a social perspective. And lastly, one of the key ones that I probably spend half my day talking to clients about is what you're doing today needs to be future-proofed, because you don't want to come in and build an infrastructure that 4 years from now you have to rip out and redevelop to make your fleet successful. So those are some of the key pillars that I'm going to talk about today, as well as go through an example of a customer of how you could take each one of these and apply it to your projects today. So let's move to the next slide. What are intelligent systems? As you look at the intelligence that's needed within this ecosystem is we've got to have smart vehicles. And the amount of electronics and data collection information we're seeing now on both hydrogen and electric buses is far beyond what we saw on diesel. Their internal systems of just management of safety and efficiency, but also how we charge them, when we charge them, the duration to charge them. And we're looking not just at an individual vehicle, but as a fleet or a subset of the fleet. We also need to consider for the first time how that vehicle impacts the building load of the grid. And so if you see on the middle chart there, you'll see a charging facility for a transit agency. And those big spikes in orange is vehicles being charged. Each one of those spikes could cost $2,000 to $3,000 to that facility if it wasn't managed correctly. So this system has to be able to work and adjust and coordinate and provide data to and receive data from multiple different types of environments. And when you start looking at just other connected systems, it's routing control, it's traffic control, it's onboard Wi-Fi, it's cameras, it's security, it's operator data and efficiency of that operator. It's health of the battery and duration of that battery to reroute them or use them on different routes. So it is a more complicated system, but one that technology has started to advance in and can really provide some very interesting models. And at the end of the day, it's how do we make it more efficient and lower the complete cost of this? The other key thing I see more and more in this, which is new to most fleet providers, is an intelligent charging platform. And what that means and why. Because if you think about it, in most organizations, the transit group is different from the energy group, which is different from the facilities group. And unfortunately, I've already seen situations where agencies have had to rip out their infrastructure because the infrastructure or transit group didn't really understand the impact of this new electric load on their facility. So intelligence is a key component of it. There's lots of different areas that are being driven to make this more successful. And one of the key pillars. So if I go to the next one, which is really renewable energy, that's probably the most connected into the vehicle, because when am I charging? How am I storing that electricity to use later? If in fact I need it to be resilient and have backup power in case the grid goes down, or in some cases, I may be just toggling between the rate in which the vehicle is being charged and how much energy I'm using from the grid or from the battery storage or from the solar. And all of that needs to be balanced to be optimized to drive the lowest cost of that solution. In many cases now, we have reference designs on high bay canopies that buses can pull in. They're modular and flexible, so you can have the charging infrastructure can be mobile versus moving buses. So there's some key things here that you need to look at in really developing your solution. The other thing that we're seeing is very rarely are you getting a situation where you're converting 100% of your fleet on day one. So in many cases, we work with clients around how do we stage the implementation? How do we add renewable as the fleet grows? And what infrastructure do you put in that is scalable so you don't have to rip up your yard 2 or 3 times? And I think lastly, which is we're seeing more and more of, is how do we use these vehicles to back up either just their facility or being able to use stationary battery storage to operate the facility in the event that you've got wildfires, you've got hurricanes, you've got other natural disasters or grid outages. So I think many of you understand renewable energy, but we do see that as a key component as you move to either electric or hydrogen fleets. If you go to the next slide. Policy. This is an area that I know we're expanding in, and I'm very excited to see some of the initiatives that are being put in place. I'm guessing many of you have seen Gavin Newsom has, who is the governor of California, has made a mandate now to convert all vehicles to zero emission by 2035. And to do that, there's a substantial amount of work that needs to be done, and policy is a key component. The grid infrastructure upgrades, the capacity at a local level, helping utilities understand how to do this and the timing is a critical component. And long-term planning of what is happening and when is a key area where we need investment from both the utility. They need to be able to rate base this, and they need to be able to provide the infrastructure and services required to customers that are moving in this direction. Because if you think about, I was just working with a local agency here in California, and the infrastructure cost to convert about 350 buses is about $377 million just in the infrastructure to support that conversion to hydrogen and electric fleets. So these are large projects that need capital, funding, and great policy to support it. The other key challenge we see right now is permitting. You know, when you start dropping in 10 to 20 megawatts of new load in this particular area, the local AHJs, I don't think have really thought through some of the permitting challenges and the difficulty in getting these approved. And so I think we need to look at our legislators to help streamline that process, just as they've done with solar and other renewable components, but really helping us be able to get through that process more efficiently and at a lower cost. Obviously, incentives or grants are a great way to incentivize the growth of this industry. We're starting to see some. I hope to see more so that we're able to get the cost of these vehicles at or below the current cost of what they're paying. And to me, that really is a seeding of the market. It's a short-term solution in order to gain momentum in the industry. And to me, probably one of the best representatives of that is the solar industry. You know, when I first started in the solar industry, if you could get a 100 kilowatt system, which was large at the time, you know, for $8 a kilowatt, that's fantastic. You know, today we're seeing PPA rates for solar at, you know, 1.2 to 1.4 cents per kilowatt hour. So just the magnitude of difference there is massive. And I think spurring this market and developing that will lead it down that same path. The other key thing on policy that I hope utilities and legislators are looking at is utility tariffs. Because utility tariffs are a great way to motivate how you want people to charge and when you want them to charge and how they can convert over to this new platform. So you're starting to see a number of utilities now come up with EV charging tariffs and giving the industry the ability to develop solutions to match those and really provide what the utility needs to make the grid more stable and to be able to create some more value in using the batteries on board or within the stationary batteries on their facilities. And lastly, standards. I was just working with a client that was very excited about the bus they were buying, and they happened to take the charging from a local agency. And unfortunately, the bus that they were about to buy and the charging they were about to buy had two different connectors. And one would think in this day and age that you should have a group of buses that have commonality in the charging ports or the charging handles and ports that they use, but that still is not there. So developing standards, not only on the technology side, the charging side, the internal equipment side, as well as integration and protocols into building management systems and other intelligence systems, I think is still key to create efficiency within the industry and be able to provide scale. So some of those are the key areas I see within sound policy and really helping grow this market. Let's move to the next slide, please. Creating value. To me, this is an area where traditionally a bus or a transit group, I mean, it was a vehicle that you filled up and you took out, and it had limited ability really to create value outside of transporting people. I think that's different now with zero emission vehicles. Today, they can become resilient, so you can operate when you don't have a fuel source from the grid, or even vehicle to grid to be able to power that building or be able to provide benefit to the grid when they need it. As I see in my area here in California with the wildfires and the amount of power shortages that we have, the ability to take a fleet and power a subset of a location or a small community is a great way to create value and get benefit and really help the community leverage this type of technology for better life and less, challenges. I think the other thing that a smart, intelligent, zero-emission fleet does is it creates a lot more flexibility in how to use it. You're starting to look at a number of ways when you have a smart system that can be used really, but from a software perspective, can change how we utilize things. It gives us a lot of different opportunities that we probably even haven't thought about today to help and leverage, additional areas to create value. I see a lot about mobile batteries. If you start taking a group of buses, and this is a hypothetical, but I see it today where you take like the Walmart bus there, instead of having the Walmart cargo on it, you put a battery storage unit, you can transport, megawatts of power to different locations in a matter of hours and be able to provide localized support when the utility needs it. And lastly, which is more of a value that is at a community or national or global level, is reducing carbon. I think many of you know that transportation is one of the highest CO2 emitters in the world, and our ability to reduce that and really provide more value, cleaner air, a lot of the challenges in global warming is a critical component to this. So I do like the fact that these go beyond just transporting people and can create a value for people at the local level, but also at a global level. With that, I'll go to the next slide. And so how do you take all of this and actually apply it today? Some of these components you may think about saying, wow, that's 10 years out. But in reality, most of these pillars can be applied today into your specific projects and how to think about it. So I'm going to give you an example of a customer that we've been working with, which is a school district down in San Diego. And interesting enough, about 7 months ago, we started working with them, and they were really struggling with, how do I start? How do I know where technology is appropriate for me? How do I even begin the process to know which charger should I be getting? And there's not a lot of case studies out there that provide best practices around how to develop a plan for converting, in this particular case, 65 buses over the next 10 years, and what infrastructure should I be putting in today? So if you go to the next slide, please, Grossmont was facing a couple of challenges. They have a mandate to convert their entire fleet by 2030. They were redeveloping their transportation yard at the end of this year and really building and ripping it out into next year. They have an aging fleet where 30% of their vehicles need to be replaced in the next 3 years. They didn't really understand how many different parts of the organization needed to be involved in this, because historically when they bought new buses, it was just transportation. But as I mentioned earlier, it's transportation, energy, infrastructure, and facilities that all need to be coordinated to make this successful. And I think the key thing here too is really, how do I pick this technology, and how do I make sure that I get something that works today? Because unfortunately, over the past few months, I've had 2 school districts that we've had to rip out the infrastructure that they just installed in the last year because it wasn't working effectively for the needs that they had. I think the other key thing for Grossmont is funding. As many of you know, the state is in a budget crisis, and funding to schools is a real challenge. And so how could we really help them from a financial perspective convert this fleet in a way that's economical and that the district could afford? So those are some of the challenges they faced. So how did we help them figure out this process and really look at some of the key things that they needed to do, which is on the next slide. So the first thing that they had to do to understand and really develop a plan was, let's analyze what you have today. So if you're a transit agency or a city or someone who has a fleet of electric vehicles, you have to understand and analyze the current routes they have. How long do they go out? When do they come back? What are the opportunities for charging? And how many miles do they drive, the age of the fleet, et cetera. With all that information, you can come back and create an analysis, which I'll show you in a second, about what is the optimal charging infrastructure, and then how do you build a staged approach to the solution. I do have some folks that have just said, nope, we're going to convert everything, and we are going to sell our newer school buses, and we're going to start this from day one. So that is an approach, but usually that is less common. The other question here that they really had to look at is, do I need to create a ratio of chargers of 1-to-1 for each bus, or do I have the ability to move buses and have staff move them to recharge them? I think the other key component here is when you start putting electrical infrastructure and charging equipment in the yard, you need to go through a redesign to make sure they all fit. Many of the facilities before used to parking the buses within 1.5 to 2 feet distance between them and on the sides, and that leaves little room for the charging infrastructure. So really having to redesign the transportation yard, especially as you add solar and battery storage to it, was a critical component of this. And I think the end of this whole solution is, does it make financial sense? How can you pay for it? How can you leverage grants and incentives and future-proof this so the district can do it once and be done versus multiple times and some of the challenges with that. So I will go to the next slide here. So the first thing that I think any agency should really look at is, what is the technology assessment? What number of buses need to be replaced? What's the optimal charging, as I mentioned? When and how much solar and storage should be added? What's the total cost, and what's the benefit from a CO2 perspective? In this particular case, we focused on a phase 1 assessment, which tackled all of those and converted the entire fleet by 2030. Some of the other advanced solutions that they're looking at is really V2G capability of for the buses and installing that, as well as optimizing the route schedules. And in some cases, we're able to reduce an entire bus needed by optimizing those bus routes. I'll go to the next slide here, which is really around building the plan. And what I think the biggest mistake most people make is they think about, and this is a list of all of the buses that they have. There's over 65, but here's just the segment. When do they go out? When can they charge? And when will they be fully, ready to go out again the next morning? The mistake I see most commonly for most agencies is they undersize the charger needed, and they assume that when the bus comes back at 2, 3, 4 o'clock, they begin charging, and they can charge for 10 to 15 hours. The challenge with that in most cases is the highest electric tariffs, utility tariffs, are between 4 and 10. So you may be paying 5 to 7 times more for that electricity instead of putting in a bigger charger and being able to charge later at a faster pace, but when energy is 1/5 to 1/10 that cost. And so that's a key component of really understanding, mapping out, and sizing chargers based upon how that is going to be utilized in their facility. And I can give you a quick example of that today, because originally they thought, great, we'll just use if you can go to the next slide, we can use level 2 chargers. And this is the list of all their buses, when they go out in the morning, how much kilowatt hours that bus would consume as being electric. And they thought a level 2 charger would work fine. Well, you can see here, this is 37 hours to have to charge this route, which is impossible. And so by mapping out and doing some of the intelligence here of what's the right charger, their fleet is a mix of 62.5 kilowatt chargers and 20 kilowatt chargers to make sure that not only does it cover what they have today, but if their routes get longer or more efficient, they haven't overinvested in the infrastructure. And I have to say, SDG&E in this particular case has done a great job in their Make Ready program of providing the infrastructure, everything up to the step out of the charging infrastructure for this project. And now you're starting to get into millions of dollars when you're upgrading the substation, the transformer, the conduit. And so this is where I think, some of the policy and programs that have been implemented here, you really need to take advantage of in California and other parts of the country, because they can significantly reduce the cost of developing these solutions. And I'll go to the next slide, which is really around the corporate redesign. And so what we have here is this is the current infrastructure that they have today. And the buses were really organized in a way that we would have had to put quite a bit of different conduit and locations to charge them. We came back with a recommendation of really having 3 major hubs for electrification. So this new design, this entire bank here will be charged in the initial phase 1. And then conduit will be run through the yard to change bank 2 on this side and bank 3 here. Solar will be added initially here, as well as carports on this side. That will be a stage to power the entire fleet, as well as adjacent property here in the last stage. So by developing this upfront, having a plan, they're able to put in the infrastructure once, have the utility pay for a large portion of that, and feel very confident they're not going to have to change this over the next 5 to 10 years. So going through this entire analysis and figuring this out for them, they feel very confident about where they're going, how are they going to fund it, what's going to happen. And I think they've got a very clear roadmap to get to meet the 2030 mandate for transportation. So hopefully that's given you a little bit of insight of not only what's critical in the pillars of moving to a zero emission fleet, but it's also giving you some what you can do today, what to pay attention to, and make this a successful project. So thank you very much. And I hope that's been helpful. And I can't wait to see you convert to a zero emission vehicle.
Thanks, Steve. One follow-up question for you is what makes a fleet particularly ripe for conversion in there? Like, what are some of the things, assuming that it's not parity to go from diesel to electric vehicle today and financing incentives, but are there particular aspects of a fleet for a customer, whether it be a school district or a private fleet, that make it readier now to explore this?
Yeah, I think many agencies today are looking at this and saying, okay, we have to replace these vehicles. And there's both federal and state mandates depending upon transportation or schools of either 2030 or 2040. And given the life expectancy of a bus is 10 to 15 years, they're having to make this conversion today. And so many of them are like, great, I know I have to do this. How do I start? And so I think it really is just getting a good plan to start is the critical component here, because you don't want to go through and have to rip these out a few times and make that happen, like I mentioned. There's quite a few incentives in the market today. Obviously, California is a leader in this, New York, there's quite a few in the Midwest, and utilities are wanting to figure out and learn this. So I think there's a great opportunity if you've got an aging fleet, you're interested in doing a what I'll call a pilot, which tends to be between 5 and 15 to 20 buses. There's a lot of opportunity for that segment to make them financially attractive and learn about how to make this transition successfully.
Great, thanks. Scott, I think there's a question in the chat.
I have a question too. I sort of follow on to that just in terms of Steve, just amazing amount of work you've done in 7 months. Congratulations. This is a fantastic pilot. I want to keep tabs on it if you don't mind. In terms of the future proofing, I mean, that's a critical discussion. And we had earlier on some, OCTA, Orange County Transportation Authority, came on and talked about doing a sort of hybrid model with EV and fuel cell to kind of like make sure that both of those technologies were evolving together to see which would play out. How much of that is happening in Grossmont, or maybe not at Grossmont, but at other projects that you're thinking about?
It is critical. Unfortunately, we're not seeing hydrogen school buses really be in the market today. So the bulk of them are looking at electric. But if you go to transportation, OCTA was one of the early ones in hydrogen. Sunline is an early one. Foothill, you've got up in the Bay Area here, AC Transit, and many of those larger players are putting in a hybrid mix of electric and hydrogen. So I think it's critical. For example, if you take a 1 megawatt hydrogen facility and you drop it off on site at a transportation, that will usually do between 25 and 50 buses. That pulls 2 megawatts of load just to be able to charge up and create that hydrogen. And so now you've got, okay, well, where is this 2 megawatt load for 2 hours going to get powered? What's the impact of it? What's the infrastructure needed? And so a lot of these are in the initial plan. Like I mentioned, on the initial technology selection is critical, but also how it goes downstream. And I think your question on future proofing is laying that out, especially in the electrical infrastructure, to say, okay, here's what we need today. Do we ever see using this for vehicle to grid? Do we ever see using this as backup power? And we can install certain components of that without, that will minimize the cost to make that transition in the future. So you've got flexibility without huge bills I guess my point is you need to think about it now so you don't have to rip it out later.
Exactly. Yeah, the future proofing scenario. So you mentioned Sunline. There's the first question we have from our audience here is regarding Sunline. I'll just read it to you. It's from Arnold San Miguel. He says, familiar with Sunline Transit work in renewables, ? How does that fit in, especially Sunline's effort to create career track vocational opportunities in this space? You know much about that, Steve?
I don't know about the career track, but I have been working with them on a plan to convert their entire fleet. And they have been very innovative, where I've got a couple of transit customers in rural areas that are able to procure land next door. So they've already moved in that process and are looking at creating a transportation hub to develop a much larger 4 megawatt solar array, a 6.5 megawatt battery storage system that could basically power their entire fleet, which would be a blend of hydrogen and electric. What I do know, though, is there are quite a few colleges. Rio Hondo is a great technology center for electrification of buses. They are connected up with OCTA, LA Metro, a few others, and they are really building pathways for technicians and excellence in this industry to really develop the skills needed to support the industry. Because it's, like I said, it's an ecosystem. And so there are some leaders in different colleges and areas that are taking those lessons learned, building curriculum, building skills to support this industry. And I think it is critical.
Yeah, great. So just one last question quickly here, Steve, then we'll move on. But question here from Kevin Best. Would it be of value to subscribe to a resource of grid-delivered, carbon-free, excess renewables from yesterday to be delivered anytime, say, midnight to 6 a.m.? ? Nighttime power has high carbon content. This could make these charging events truly carbon-free.
Yeah, and that's really what we're seeing predominantly used today is through battery storage. Now the question becomes, and unfortunately, if you look at most of the EV charging tariffs today, the lower or super peak is in the middle of the day, somewhere between 8 and noon. So in the slide that I happen to show where we're recharging, almost all of that is happening in that time frame because it's a lower tariff structure, and most of that's being powered by solar. So in that way, both with creating good tariffs that support that, as well as an infrastructure that supports it, you're able to repower these vehicles with clean, renewable fuel.
Yeah. Well, Steve, fantastic. And before maybe I'll thank you, Steve, on behalf of Trip, if you don't mind, Trip. And I want to fantastic overview. Again, we'd love to stay tuned. We'd love to get you more involved in our working group at Sustain Southern California. We have these ongoing discussions regularly. Want to learn more? Just keep tabs on that. So, Steve, if you'll stick around, maybe we may have more Q&A toward the end of the session. So that'd be fantastic. So thank you very much. Before I turn it back over to Trip to continue hosting, I want to just to have a quick shout out to Ravi Kondagunta, co-chair here for this event. Ravi, do you want to say a quick few words?
Thank you very much for allowing me to co-host it. I'm with Traction Labs. We are a boutique consulting agency, and I'm looking forward to a great conversation. That was a great conversation, Steve. Thank you for that.
It was excellent. Thank you very much, Ravi. So with that, Arnold, San Miguel, I noticed you had a couple other questions here. We may get back to those toward the end of the session if we have time. So we'll get back to you hopefully. With that, I'd like to just turn it back to Trip to continue on with our discussions. Thank you.
Sure. Thanks, Scott. Thanks, Steve. It's my pleasure to introduce our next speaker. So Jim Meisner, and he and I had a chance to be able to connect yesterday. Jim is definitely a forward-thinking, has been thinking about the future of mobility and particularly connectivity and mobility for quite some time. So I'm going to read his bio. Jim Meisner is Senior Director of Product Management and Global C-V2X Ecosystem Lead for Qualcomm. He develops and executes Qualcomm's C2VX deployment strategy across global regions and works with roadside and automotive stakeholders, enabling software, hardware, stack suppliers, and internal teams to accomplish broad C2VX deployment. Previous to Qualcomm, Jim led the automotive standards team at CV2X and was a major emphasis as well. In addition to his roles at Qualcomm, Jim serves on numerous boards and committees and was a pioneer in the vehicle highway automation and vehicle safety communication in the mid-90s. So Jim, look forward to your talk today, and if panelists want to submit questions, we'll take them at that end. But Jim, I'll let you take it away.
Thank you, Steve. This is a departure from the very interesting previous talk, and I'll do my very best to make this interesting. But I'm going to talk about the wireless infrastructure, but not in concrete ways. I'm going to talk about initially aspirationally. Before we do that, I have to give you a little bit of some requisite background of who we are at Qualcomm. Trip, do I drive the slides or do you? I'm not sure.
That should come from Adam.
I'm sorry? Okay, so I'll get to the next slide then.
Yeah, just cue me. This is Alan. Just say next slide.
Alan,
I got it.
slide 2, please. Yes, please. Thank you. Thank you, Adam. So there's a couple of we's here. First of all, the we on the above is Qualcomm. And I'm the Qualcomm guy who does certain things with CV2X, and I'll describe that in a moment. But more broadly, I merge what we do in the automotive business unit to the overall corporate endeavor, and then what we do in transportation, because I'm imbued with about 30 years of experience in transportation. So when we at Qualcomm, obviously, you know of us for providing basically the technologies that underpin the connectivity that you have in your hand, and you may not know the connectivity you have in your car as well, in addition to a lot of the onboard compute. With that, we're always aware of our users and applications, and we have a whole set of platforms. This is a little bit from the auto perspective, but certainly we have other platforms that serve the mobile network operator, enterprises, internet providers, and ultimately you. But we're aware of and work closely with infrastructure owner operators, be they road infrastructure owner operators or other types of infrastructures that fit into the fabric of mobility. And when I say our technologies, this is basically, without going into the excruciating detail of product names, what we offer within our automotive business unit. And you can see that we have a DSDAs, dual SIM, dual active. These are arcane terms. But the takeaway here is that we're all over in the car, where we have virtually every automotive OEM in the world as our partner and as our customer. So go to the next slide, please. But this all has to fit in within a vision. And some of that vision, I'm proud to be part of working in that from a transportation perspective, and the idea of green mobility and active traffic management. And the fact that you can use current and emerging 5G networks to influence basically the carbon footprint of the transportation enterprise. You can do this, pre-trip by influencing, the trip generation, whether it be at the trip. You can do this en route during the trip, and that you can influence mode. Basically, if you have a ubiquity and multiple heterogeneous connectivity options, you can influence things very strategically, all the way from managing policies on demand, all the way through the actual safety data exchange. So from our perspective, cellular and transportation networks are intertwined. Certainly, cellular networks transcend transportation, but since transportation is so important to our enterprise and very much into part of the greenhouse gas equation and what we're trying to do with sustainability, that's what we're all about. And so we want to be able to transform quantifiable benefits for everyone by delivering products certainly that have KPIs that match that. And so we have, and this is a general slide, but certainly we beat our chest, but for a good reason. We do a lot of technology leadership in particular, and what this talk is about with the 5G. And for us, the 5G and this whole idea of enhanced mobile broadband plus some other interesting features I'll talk about in a transportation context, we think set the stage to provide that type of wireless infrastructure to enable what many of you are doing perhaps in the hard infrastructure and in operations. Go to the next slide, please. So this is another aspirational slide, but it gets down to a little bit more specifics into some of the applications that could be envisioned. So certainly there are some, and I know that Arvind Kalaes of Volvo has spoken at this conference, and he probably talked a little bit about truck platooning, and certainly there's a communication that would be center of that. But perhaps even larger than that is the fleet management. In fact, Qualcomm started off as Omnitrax in doing that type of fleet management. But we've graduated into understanding that fleet management is part and parcel or user of the types of technologies we provide. I talked about trip and load planning, and that would benefit a whole lot of players, but the stakeholder that would primarily benefit is you, the personal traveler. And also in terms of traffic management, if you're the road infrastructure owner operator and you want to have a TMC, be it real and hard and in concrete as in now, or perhaps in the future where it's a virtual TMC, you bring more and more to the cloud and you have basically a very thin edge, but still an edge, and then you have multi-access edge computing or MEC, or you go all the way through the core network. We work with partners to ensure that the technology we have makes these things happen. Next slide, please. This is when it starts getting into, so in the end, certainly we talk altruistically and appropriately about societal benefits. But in order to make this happen, there has to be a business, and the business doesn't necessarily have to be the public sector, which pays the private sector to deliver services which are good for the citizenry. There's a certain part of that. So when we think about this and we talk to our customers, and now we're talking very specifically now, for example, to our OEM customers or to other types of service providers. So for us, and this is almost, actually it is, a non-negotiable aspect, is road safety comes free. So whatever we can do with communication to ensure road safety, at least that data exchange is free for our perspective. And there's a public gift of spectrum to hopefully allow that, and some regulatory changes that are happening in North America and have already happened in China to really make this happen. Traffic information could be freemium. It could be a little bit of a price, but it could be, you already get it through over-the-top services delivered through core networks, and you know that. But then there's other things that could be premium. And those could be convenience features, but some of those for us could be management features. And so, and there could be context-based, and we offer a card to cloud service, which would provide some of these feature management. You can view this as customer relationship management, say from the OEM directly to the driver of the car. You can view this as a way of doing SKU management, because you can kind of add features in software more and more, and you can do a soft SKU management with these over-the-air updates. So for us, there's multi-tiered services, but certainly we do things with compute, and talk about that a little bit later, and we do autonomy. But what is pretty important to us is the ability to provide, again, this underlying overarching connectivity fabric, which again starts at 5G. Next slide, please. So this may be to some in the audience a really exciting slide. To others, it's just a bunch of acronyms. But let me try to explain the acronyms and try to inject the excitement. So within this global telecommunications proposition, there's something called 3GPP, Third Generation Partnership Project, and it does the international global specification for what we call 5G. And what's interesting about that is you, the consumer, we, the consumer, where we want an ever increasing number of applications. So there's feature growth, and that feature growth is driven a lot by invention, and yeah, we're part of that, and innovation and standardization, because interoperability means a heck of a lot to communications. But within that, there is a new train. This is a train that stops every year and a half or so with these releases of the 5G new radio. And within this 5G, the 5G that you know about and that I talk mostly about is what we call enhanced mobile broadband, so EMBB. By the way, our very good corporate communications folks probably thinks that everyone is a radio engineer. So yeah, EMBB is enhanced mobile broadband. And this starts to transcend the types of things you could do with a cell phone. And it goes into lots of aspects that are interesting, policy-oriented, deals with spectrum like private networks. You can start to do things to virtualize RAN. You can start to deliver at the radio access technology level, position information. So 5G will expand to become basically this all-enveloping bigger thing. But 5G is here now. You can go to your Verizon store or whatever and buy a 5G handset. And certainly you see 5G being instantiated in various forms, mostly for densification, because someday we're going to get into millimeter wave and really big broadband, and you can start doing more and more applications. So that's basically 5G in a nutshell, except for one aspect, which I'll start to talk about in the next slide. Please go to the next slide. Actually, two aspects. I'm not going to talk much about narrowband IoT or IoT in the expansion, but the fact, very simply say that everything has an IP address, and then you can have basically this ubiquitous type of connectivity fabric, maybe short range, and you can start to enable all sorts of interesting smart appliances and smart things. But this is a derivative of all of that. This is the other aspect of 5G I want to talk about. It starts to get more into what I think about every day in my day job, is that direct communication component, or what we call cellular V2X. Now, you may have heard that, and there's a little bit of a food fight in terms of which radio protocol is preferable in North America. But let's transcend that. Let's look at the lower left-hand corner, where we talk about V to everything, and certainly V to N is the current LTE and emerging 5G networks type of connectivity. So let's call it V to X, and imagine, because it doesn't take much because it's happening as a non-fiction imagination, is that this V to X happens in one telematics control unit. And this is why I deliberately put the 3GPP slide up there, because there is a train that's moving, the transportation is being mainstreamed onto, which provides you concurrent network and short-range connectivity. That may not mean a lot to some in this audience. I hope it means a lot, because you're going to see it on the roads that save lives. But if you are offering a service, let's say that you're offering a transportation network management service, and you had hyperlocal information provided at the same time as you have network information, you can start to manage that intersection, that road link, or that network in a much better way, particularly if you had this V to N to be this enhanced mobile broadband. So we can see a future, and hopefully I've painted enough of a hint of that future where you can see a transformation, not in just the way that safety services are delivered in a telematics control unit that will be in your car anyway, but also in terms of how this would help the traveler maneuver very safely. What's interesting here, at least to me, and I hope it is the V2P part, certainly. Putting it in 3GPP standards means that the same types of standardized interfaces that go into your handset will go into cars. I can't promise this now because it's a pretty difficult problem, but there is a future which we are working toward to paint, which has the handset and the personal device communicating and in this environment. So we talk about sustainability, certainly, and I'm straying a little bit and talking about safety, obviously. A safe traveler helps in sustainability, but you can imagine the operational efficiency, and you can imagine it both from the perspective of the individual traveler, or you can imagine it from the fact the city that has to manage all of this and how resources are deployed, or how you can do, again, this demand management, or try to do some enforcement as to who takes the road at what time, maybe based on pricing strategies. What's important to us, and actually we've done some studies to show how this helps in terms of, say, fuel consumption, is this 5G roadmap that we have already been instantiated, at least in standards, by what's called on-the-fly connectionless group. And I'm very conscious that not everyone in this audience is a radio engineer, but we probably have some. But imagine at the lower layers, the FIMAC, the radio layer, that you can form and deform groups of cars without going up the protocol stack. What does that do? It gives you unprecedented levels of reliability and latency to have cars to start to communicate, or cars and pedestrians to work in clusters. For us, and we're one of the few companies who can see this clearly, that is a key, not the key, because autonomy is happening anyway, but a key to autonomy, particularly in cities. Now, the studies that we've done have shown that this does a lot, basically, in individual movements toward making the traffic system, particularly in urban grids, which are quite saturated, much more efficient. And we've shown gains, tremendous gains, and I can cite those studies a little bit later, in terms of reduced travel time, which is convenient and good, but also in terms of reduced fuel consumption or energy consumption as you go about. So we see this in the roadmap, and the standards to do this have already been done. And it's important to tell you that those standards move every year and a half, often with features depending on demand, and there is some demand for this. So expect a roadmap that includes the vehicle, and someday will include other road users with this user equipment that will participate in this 5G transportation endeavor as we continue to march into, later in 5G and soon enough into 6G. Next slide, please. So I'm bringing it a little bit higher, CV2X is kind of my functional title, so I had to bring it up. But we at Qualcomm, see the combination to be quite beneficial, and certainly to the theme of this meeting and conference, the clean environment, which I touched on. And certainly autonomous driving could be part and parcel, and we offer what we call the Snapdragon Ride. Those of you who you can dig into it and what we've published, but you can see that we're offering basically an application processor that can go up to the levels of autonomy that's scalable. And we also offer a full stack, because in order to develop that chipset solution, we have to figure out how to make a car drive autonomously. And then we offer car to cloud. But when you add the three, the direct communication link, our work with in-vehicle processing and autonomous driving, which segues nicely, by the way, into infotainment, because there's a big compute demand for that. And talk about car to cloud, we believe that we have set the stage for a next generation intelligent transportation system. And again, the clean environment isn't a benefit, but all these others that you can see on the left go hand in glove. I'm going to spend a few minutes talking about new business opportunities, because in the end, we want to show value to everyone in the chain, right? So there has to be basically a sustainable business in this business of sustainability. So next slide, please. So this is not the only business opportunity, certainly, and there are many others which are more conventional. This is what I spend a fair bit of my time and my team's time thinking about these days, and it's happening. For example, it's happening in China. I keep on mentioning China. So I stay up late at night talking to my Chinese colleagues. But I know that very resolutely this is not China, but there are some things that we can learn from there. In fact, in China, there is a national intelligent transportation cooperative vehicle, ICV concept, that's instantiated in a 4-year national goal, and there's a lot of I2V command in order to really make the system work more efficiently. Now, I don't expect that to be transferred part and parcel, but some interesting ideas. You start with that connectivity. You add onto that a very intelligent infrastructure where the processing and the compute can happen at the edge. It can happen near the edge. It can happen in the core network, or better all in a 5G fabric. It can happen all over. You add to these the ego vehicle types of devices, and ultimately what you have is a very efficient system and businesses to be made, because you have, you can do a high definition map, upload and download. You can provide other types of services through the network operator that transcend safety. There are a whole bunch of revenue models. In this particular audience, I would say some of those revenue models could be greening, if you can catch this 5G wave. So if you go to the next slide, please. And I think I'm near the end. So we believe we're uniquely positioned to power this intelligently connected future. I know I painted a rather broad brush about something that may seem a little Buck Rogerish, but not to us. We are part of driving this change to be faster. We're on top of and driving some of these global changes. And we certainly know the power of what some of our onboard processing and what some of our communication links are. And we're quite excited about 5G in the context of transportation, and specifically this group in the context of sustainable transportation as we endeavor to have a more sustainable future all around. So with that, Trip, I think I'm done with my prepared remarks.
Great, thanks, Jim. I think we have time for one question, which is, you talked a bit about, you mentioned autonomous vehicles and how 5G can help with, well, I guess the question is, how does 5G really help with autonomous vehicles? As that technology is developing, and clearly there's more connectivity needed in order to make those safer and more reliable. What's the connection there?
Well, I mean, that's a great question, because there are differences of opinions, because none of us have that great crystal ball into the future. But there is, and as you know, a pretty active development of autonomy that's all vehicle centric, and for good reasons, because the infrastructure is not known, and can you trust a message that's not authenticated, that's not part of you? But let's start with what all the autonomy developers realize, that there needs to be some provision of external information, at the very least a high definition map. So this idea of wide area network connectivity is a given. And so are the updates, and so are the deep learning. So there's connectivity, yes. Our hypothesis, which is yet to be proven, is that the 5G with its enhanced performance to do side link, or this direct communication to have vehicles directly talk to one another. And to be fair, there are others who say, let's go through the MEC, not necessarily vehicle to vehicle. That means go a little bit to the core network, but not all the way to the end. Go just to the edge. This edge processing through a network operator is another way to deliver these, what we call ultra reliable, low latency communication. So that's going to be a quiz, URLLC. But if you can provide that reliability, high quality service with the types of low latency, then 5G and these communications inventions figure prominently in autonomy and will make your autonomous vehicle that much better. And we're hoping to realize that vision.
So you mind if I chime in here, Trip? All right, thanks. Yeah, so Jim, it's great to see you again. Thank you for joining us. This is fantastic. You're always seemingly one step ahead of all of us here. And I'm curious, a question that I have and that I hear a lot is that, with technologies evolving so quickly that it's sort of bypassing policy and legislation. I mean, is policy, are the legislators out there able to keep up with you guys, or how does that stand now?
Well, I'm an engineer, so but B, I'm a product manager. So yes, so I do have to, I'm forced to pay attention. and we do. We're doing the best we can. But certainly, one thing about, and it's a truism that I learned when I had completely dark hair, was that technology can be used to help policy, but it does need policy. You're right. But technology does not substitute for policy. So good policies, then you can use technology as a tool. So yes, we want policy to lead at the edge, but a policy of sustainability. For example, the European Green New Deal, which is exciting and is in line with the Paris Accords. Those types of policies will let technology be filtered or focused on what we really need to accomplish as a whole.
Yeah, well, I appreciate that very much. I mean, it's a tough one to answer. I know it's one we've been dealing with ourselves. If you could answer this next one fairly quickly, and we'll move on if you
Sure.
don't mind. There's a question from Arnold San Miguel again. Does CV2X mean that different private companies could offer services in certain geographies? So could be moving from one provider to another as travel from city to city or neighborhood to neighborhood in dense downtowns?
That's a great question. Remember I had the V to X and I had various values for X or definitions of X, but the V to V, the V to I, and the V to P happens in our minds in unlicensed spectrum. So there's no particular, you're not beholden to an operator. It's without a SIM card, that transaction. So certainly the safety services or the hyperlocal services, it doesn't matter. There's no carrier involved. But to get the carrier involved just makes it that much stronger and makes more end-to-end. So the V to N is the aspect of it. So it is portable in terms of local services, but in terms of the, say, the network types of services that you need, certainly it would depend therefore on the types of business deals that we're thinking about in the future.
Well, thank you. There is another question, but we'll maybe leave that one for later on.
Sure, I can hang out.
On behalf of Trip, maybe, and Trip too as well, but thank you very much, Jim. That was a fantastic presentation. And Trip, turning it back over to you. You're muted. Trip, you're still muted.
Rookie mistake.
There you go. No, I did it on the first day too. It's all right. No.
Thanks, Scott. Jim, thank you. I love your presentation and really sort of inspiring thinking about the future. So we have two speakers next from UC Irvine. The title of the talk is Driving Smart and Clean City Innovation at University of California, Irvine through mobility and connectivity research and initiatives. So we have Michael Hyland, who Michael is the assistant professor of Civil and Environmental Engineering at the University of California, Irvine, where he's affiliated with the Institute of Transportation Studies. Michael works to improve the modeling, analysis, planning, and control of urban transportation systems to create smarter, more efficient, sustainable, and affordable cities through research and teaching. His research interests include emerging transportation systems such as bike sharing, ride sharing, and shared use autonomous vehicle mobility services, as well as the integration of these emerging services with existing transportation modes. Along with him is Blake Lane. So Blake Lane is a senior scientist at the Advanced Power and Energy Program at UCI. Blake's research and focus are on optimal rollout of alternative fuel and vehicle technologies, techno-economic and market projections for alternative fuels, and the analysis and integration of the transportation sector with the electricity and hydrogen power grids. Blake has initiated research thrust for cooperative driving automation impacts on zero emission technologies within the Horiba Institute, which we'll talk a little bit about for mobility and connectivity. So excited to have you guys on, and particularly I think making the connection between sustainability and our transportation future. So I think, Michael, are you presenting first?
Thanks, Trip. Blake's going to take the first two slides, and then it'll be me, then it'll be Blake again. So go ahead, Blake.
Yeah, thanks, Trip. We'll be switching it up on you just for a bit. So thank you for this opportunity. Next slide, please. Just wanted to introduce so Mike and I work in kind of slightly different areas, but very much high collaboration between our two areas. And this slide here diagram kind of represents a bit of that intersection. So as Trip mentioned, I'll be talking primarily about HIMAC, and then Mike will be talking about his work in smart mobility. But this diagram here shows HIMAC here on the left, and in the blue of this kind of Venn diagram, and then TML2, or Transformational Mobility Living Laboratory, in the tannish color on the right. And so really the interplay here is that APEP and HIMAC, this new institute that we've got, is kind of generally focused on energy. And HIMAC will be a controlled laboratory. I'll get into that in a bit more. And then ITS generally has a bit of more experience in the field, test beds, and those sorts of things. And so really what we're doing is kind of a synergy between the two, what we learn in the field, bringing that into modeling, simulation, and then kind of feeding off of each other with that. So with that, I'll hand it off to Mike.
Thanks very much, Blake, and you can go to the next slide. So I'm going to spend my time today talking about an NSF research grant that the team at UCI got recently. That's me and my 5 colleagues, fellow faculty in ITS at UCI. So basically the gist of the presentation will be breaking apart what this title means, but addressing unprecedented community-centered transportation infrastructure needs and policies for mobility revolution. You go to the next slide. So this is very goal-oriented. It's part of NSF's approach for funding this Smart and Connected Communities Planning Grant. We're aiming to improve communities at multiple levels through sustainability, livability or accessibility, and mobility. We're aiming to do that through decision support. In particular, we're aiming to support decisions in terms of infrastructure upgrades, infrastructure investments in general, as well as through new transportation policies and regulations. And obviously, transportation mobility space is a huge space. What we're going to be focusing on are the new innovations and technologies in transportation, which relate to kind of shared mobility, sharing economy, Uber and Lyft type mobility service providers, as well as connected and automated vehicles and the developers of those technologies. Next slide, please. So we're getting a layout now, kind of what the challenges and problems are. And this is kind of core to what NSF is looking for in this type of research. Kind of 2 elements, that's societal problems or social problems and technological challenges. So as far as we see it, societal problems are not huge problems themselves, but I'll mention anyway. The real viability of mobility service providers like Uber and Lyft and connected automated vehicles is what I would call uncertain at this time in terms of not necessarily their viability, but when they'll be viable financially, technologically, and politically. And there's also a need, we have planning agencies that do this, but for planning and regulating around these mobility service providers and connected and automated vehicles in order to gain their the benefits associated with these, which are typically associated with improved mobility and accessibility, but avoid the pitfalls. So avoid the increased congestion, avoid the negative emissions, etc. From a technological perspective, and I'm an engineer, so we do technological research. Transportation planning agencies have these very complicated, complex system models, but they're built more for the transportation system of 10, 15, 20 years ago, and don't fully incorporate all the new technologies that are in that space. And one other thing they don't tend to do is optimize policies, right? They have these simulation tools, these modeling tools that can evaluate, but what we're trying to do is build optimization techniques on top of the evaluation models. Next slide, please. So the next 2 slides will be kind of comparing, contrasting the old transportation system and old transportation system models with the current or future transportation system models. So put pretty simply, there's really 2 main behavioral players in older transportation systems. Those are the travelers and the people that are using the transportation systems. They're making all kinds of choices, which routes they're going to choose, which routes they're going to choose, routes, modes, when they're going to depart for their trips, where they're going to conduct activities, what activities they're going to conduct. And there's also the transportation infrastructure managers, which is probably too narrow of a term. This is anyone in the public sector that's involved in the transportation space. Policymakers, planners, regulators, traffic engineers, infrastructure managers, etc. And these folks were responsible and still are responsible for where the roads will be, how many lanes there will be, how the intersections will be developed, how they'll be controlled, the communication technologies that support that infrastructure. If you think about the transit side, where the transit lines will be, how frequently they will run, etc. Next slide, please. So what we have now, or at least as of 5, 6, 7 years ago, is a third set of players in the transportation space. And those are the mobility service providers, while they don't have connected and automated vehicles yet in their fleet, they are likely to have those vehicles in their fleet in the next 15, 30 years. That's not my area of expertise. I'm not going to guess a timeline. So these new players are, in a sense, demanding infrastructure from the transportation infrastructure managers, while also supplying mobility to the traveler. So they're kind of at the edge of demand and supply. They're making decisions about how much sharing there will be in these fleets, what the fleet sizes will be, how they're going to price their services. You can also think about vehicle design, which I don't do much of, but vehicle size, what the seat arrangements will be, where the sensors will be on the vehicles, etc. Next slide, please. This is what I was hinting at earlier. So the way transportation system planning models, for the most part, work now is on the left-hand side. These very high-resolution, data-intensive travel demand and transport supply integrated models. I mean, there's been years and years in development on those. But for the most part, those actually, what we're going to do is incorporate mobility service providers and connected automated vehicles into those systems. But the right-hand side is, I think, where the real innovation is going to be, which is determining how to upgrade your infrastructure optimally. And when we're talking about optimally, you need an objective function. And that objective function is really about whatever the community itself is interested in. So are there challenges related to sustainability? Are they related to mobility, et cetera? And you don't need to get into the details here, but basically, we're going to inform that optimization model using the existing evaluation model on the left-hand side. Next slide. This is my last one. So just to close, I'm going to cover what research questions we're trying to address, or what research questions we are addressing right now. So the first is trying to understand how mobility service providers right now are impacting our transportation system. I mean, so there's been a lot of research on that, including some of my own, that suggests that they are increasing congestion, particularly in large, dense metropolitan areas across the country. But at the same time, they're providing valuable mobility to people of all ages, all income ranges, all education levels, et cetera. The benefits are more towards the high income, high education people, but all people are receiving benefits. The second research question are, what are the potential impacts of specific policies on the transportation systems, and those policies being related to the service providers and the CAVs? So some of the stuff we're looking at are congestion pricing. So that's managed lanes on highways, that's parking pricing in cities, that's incentivizing people to share rides in either transit vehicles or Uber and Lyft type vehicles, et cetera. And then last, what are socially optimal connected automated vehicle related infrastructure upgrades, and what is the deployment time frame for those upgrades? So Jim was hitting on this a little bit in the last presentation, but I tend to agree with him that communication technologies will be very valuable for vehicles, but so will simple road infrastructure changes, allowing some vehicles to actually have protected left-hand turn lanes, maybe changing on-ramps onto highways. So how would a public sector, whose main goal is not to necessarily enhance the profits of private company, but to support the people that live in that community, how would they make infrastructure upgrades for their own objectives? And I'll pass it over to Blake then for the next part of the presentation.
Thank you, Mike. So switching gears a bit into the Hariba Institute for Mobility and Connectivity. And so this is a new institute called HIMAC for short. It's a long name. Where we're looking at advanced zero-emission mobility research and testing as well. Next slide, please. So to give a little bit of context, HIMAC is actually situated within UCI's Advanced Power and Energy Program, which itself is a very interdisciplinary center, much like ITS is. And we can see on the very bottom here, I highlighted the red arrow where HIMAC is. And so it's kind of the groundwork, the hands-on, a bit more fundamental testing and research that leads into the whole breadth of research that we do at APEP, starting most directly with what we have here, ESII, Energy Systems Integration and Impacts. So this is where we're looking at the electric grid, hydrogen grid of the future, transportation, zero-emission vehicle technologies, and very importantly, the climate and air quality impacts of these technologies. And we also do research in renewable fuels, energy storage. We have the National Fuel Cell Research Center as well as kind of the genesis of APEP, which was the UCI combustion laboratory started a few decades back. So next slide, please. So a little bit of news. Professor Stamenkovic is the newly appointed HIMAC director. Actually, yesterday was his first formal day as the director. And he comes to us from Argonne National Lab. His area of expertise is electrochemistry. So you might be thinking, you know, how does that fit in? And it's very closely tied with the zero emission technologies that will be underpinning all of these vehicles that we have today, as well as most likely all of the vehicles of the future and so many other aspects of the grid and so on. And so with this appointment, UCI, we have, I would say, world-leading electrochemistry engineering with Professor Stamenkovic, as well as our already existing faculty, Professor Zenyuk, Antanasov, as well as several others. I put here just a clipping of a recent article in Science from Professor Stamenkovic looking at the future of lead-acid batteries, and typically not considered for vehicles, but again, as I mentioned, these can play a pivotal role for the electric grid itself for stationary applications. Next slide, please. So HIMAC is actually composed of four somewhat distinct but very interdisciplinary, again, separate labs. So starting from the left here, the Vehicle Evolution Lab, focusing more on the powertrains themselves. The Grid Evolution Lab, which is, as you would imagine, focusing on the electric grid as well as the hydrogen grid. Connected and Autonomous Mobility Lab, so that's a little bit closer in line with what we're talking about today for this day's topic. And then lastly, kind of in a support fashion, the Analytic Laboratory. Next slide, please. So as I mentioned, these four labs have a lot of interconnection, and it's really challenging to kind of tie it all together. But I wanted to highlight a few of the key areas that we're kind of getting synergies between these labs. And so starting on the top left with the GEL, Grid Evolution Laboratory, this is something that is currently in existence. We've been using for the past several years. The three others that we're about to dive into are under construction and should be fully built this fall, this winter, in the near future. So with the Grid Evolution Laboratory, what we're doing is looking at various types of distributed energy resources. So batteries, fuel cells, we have renewable energy generation, as well as electrolysis for the hydrogen grid. UCI actually had the nation's first power to gas demonstration where we injected hydrogen into the natural gas pipeline on campus, which interestingly is a microgrid itself, which we have islanded as well. So we've got a lot of great research coming out of the Grid Evolution Lab. Tying that into the Vehicle Evolution Lab, VEL, this is something that, again, we're developing right now. I'm kind of in the finishing stages of tying everything together and commissioning. But here we have a vehicle dynamometer, very important for vehicle research, as well as two chambers for electrochemical devices. So we're looking at, again, zero emission technologies, so batteries, fuel cells, perhaps anything in the future that can come along the same lines as well. And then down on the bottom right, we have the Connected and Autonomous Mobility Lab. And so this is kind of where we're hosting our cooperative driving automation research. So cooperative, automated, connected vehicles. And so here we have kind of a multi-pronged and multi-level research take on this. So multi-pronged in that we are hosting a couple different kind of capabilities in terms of commercially available software to simulate vehicles and to test out different, say, sensors, charging capabilities, and so on. And then also a more research-oriented capability. So we work quite a bit with car makers and other entities that like to see a commercial aspect, but of course we're a research university, a research institute, and so we have those two aspects as well. And then I mentioned multi-level, so that includes simulation on the computer, as well as kind of hardware in the loop testing, so smaller scale. If we want to connect these simulations to the reach-in chambers down below so that we could connect the batteries of the vehicles and have that hardware in the loop testing in real time. Similarly, on the bottom of the camel, you can see the test bed that we have. And so this is kind of our kind of scale sensor and electric vehicle, kind of robotic vehicle, you can imagine. so scale testing. And then third and finally, and that's kind of where we get the tight integration with ITS, is bridging and scaling up to the campus size. And so we outfitting vehicles to be autonomous, connectivity, and those sorts of things. And then lastly, on the bottom left, the analytic lab. And this is kind of where we're analyzing the different electrochemical components, so batteries and fuel cells, testing for degradation, efficiency, and those sorts of things, and looking at how we might be able to take batteries that were previously used in vehicles and give them a second life as a stationary power application. Next slide, please. So I'm going to go through a quick set of a few slides here, kind of demonstrating the different setups that we can have between the vehicle and the grid evolution laboratories. And so on the left, we have the grid with all the different power generation sources, the hydrogen and the electricity. And then on the right, the different electrical and mechanical components of the zero emission vehicle technologies. So next slide, please. This highlights the battery electric vehicle components. So we can see we have got charging. We can test out different charging protocols. Next slide. For fuel cell electric vehicles, so different ways of producing hydrogen. As I mentioned, we have that on site. Whether we want to use low or high temperature fuel cells, electrolyzers to make hydrogen, put those into the vehicle evolution laboratory. And I should mention that we have trenching connecting these two. They're not necessarily side by side. They're about 20 yards or so apart, but we have trenching connecting so that we can take the electricity produced in the grid evolution lab and feed it into the vehicles on the dyno in the vehicle evolution lab. Next slide, please. This is kind of my personal favorite, the plug-in fuel cell electric vehicle, combining the plug-in capability of the battery electric vehicle with the fuel cell kind of as a range extender and fast refueling of the fuel cell electric vehicle. Next slide. So as I mentioned, electrochemical components, so both stationary as well as mobile, so fuel cells and batteries. And then lastly, next slide, is the mechanical component. So gas turbines and hybrids in conjunction with fuel cells, as well as the electric motor and generator of the vehicle itself. Next slide, please. And so kind of tying this all up together, as I mentioned, 4 different labs that we have. The Grid Evolution Lab already kind of producing great research, the other 3 shortly to come online. But really we see both research as well as service capabilities for this lab. And so just to point out a few of them, for the vehicles, we're looking at different powertrain configurations. As I mentioned, the plug-in fuel cell electric vehicle, something that's not really on the market yet, but perhaps could be a pivotal player in the future. Grid Evolution Lab, as I mentioned, we're a microgrid, so we have kind of a scale of different, a wide range of scales that we can test these electrical grid and hydrogen components on. The Camel, where we're focusing on cooperative vehicle driving, communication, autonomy, different sensors. And then the Analytic Lab, where we're developing new materials for batteries and fuel cells and trying to improve their durability. So with that, I think next slide, just kind of ending where we started to show off the collaboration. But thank you, and looking forward to any questions and discussion.
Great, thank you, Blake and Michael. Super interesting. I would love to take a tour of that lab at some point. It looks like a fascinating place. A couple questions. So Blake, I think this may be to you. How do you expect the contribution of total emissions of both the transportation sector and the power sector to evolve as we get in more connected and automated technologies and vehicles begin to roll out or already rolling out?
Yeah, that's a really great question, especially as California, kind of where we're focused at, is really kind of leading the country in terms of renewable electricity. And so we'd like to use that as much as we can. Really, it comes down to how the integration of the transportation sector and the electric grid combine. And so, as I mentioned, we're going to be having, as many people mentioned, you know, we're getting electric vehicles, whether they're plug-in electric vehicles like batteries, plug-in hybrids, fuel cell electric vehicles. Of course, you can make hydrogen out of electricity. And so really with that, it's not going to be surprising if we see an increase in the electric load. And so it's really key to make sure that if that happens, that happens in line with an increase in renewable electricity. There's been discussions on, you know, how does automation impact the amount of miles traveled. That's something that we don't really have a an expertise in, but other researchers may as well. If we're going to be having cheaper automated vehicles, perhaps miles will increase. And so even though electric vehicles are more efficient, if we have a lot more miles, that kind of may counteract that. And so it's really going to be an interesting interplay. But at the end of the day, we've got to adopt more zero-emission vehicle technologies, both batteries and fuel cells as appropriate, as well as increase the renewables on the grid, because that will lead into the transportation sector as well.
Yeah, I mean, it's a fascinating challenge, especially Governor Newsom's announcement last week of banning internal combustion engines by the year 2035, are just the interesting challenges that will bring to the grid with all of that increased demand. Michael, I think this is a question for you. What are some major research challenges that need to be addressed in order to transform the cities and transportation sector?
I'll actually hop in on the previous question real quick and then switch over to that one.
Please.
So the governor actually called out a study that's going on right now amongst basically at least 4 or 5 UC campuses, of which I'm a part of, that looks at exactly how we can decrease energy consumption and emissions in the transportation sector as kind of an impetus for this new policy. And as exactly what Blake pointed out, we need to switch to more environmentally safe vehicles, but also we need to decrease the amount of the usage of those vehicles, which could be in contrast if electric vehicles are cheaper, if connected automated vehicles make it easier and less onerous to be on the road. So we're looking at policies, which I mentioned earlier, like congestion pricing, like possible increases to the gas tax again, but maybe more importantly, land use changes and increasing housing near transit sites, as well as in already somewhat dense but medium density areas. And then in regards to what research challenges, we need to transform cities in the transportation sector. So I think the 2 main ones have been hit on already, which are electrification and automation of vehicle fleets, which are enormous challenges, both from a technological perspective as well as from a public policy perspective. I think another one is in regards to who's going to pay for smart city technology within our cities, given who's going to benefit from it, who's going to deploy the technologies, et cetera. And that's, as far as I can see, a pretty open-ended question right now. Obviously, taxpayers can pay for it, but that's going to require increasing taxes, which is politically challenging. There's the companies that can develop the technology, but they're not going to directly benefit from it. It's the people themselves that are going to benefit. And then the last thing I'll mention is that we're partnering with the San Diego Metropolitan Planning Organization on that NSF grant I talked about. And they're developing something called the Next OS, the Next Operating System, which they're calling the brain for the transportation system. And that's all about communication technologies and data flows in order to improve the transportation sector, which is, in our experience, a lot easier to say than it is to actually implement. You can collect the data, but you need to make good, smart decisions with that data, and that's a real challenge.
Yeah, those are big. Yeah, and it's who's going to pay for the systems is a really interesting one, because particularly in the environment that we are in, having cities pay for it is looking increasingly unlikely until things seem to turn around. Scott, are there any questions from the audience?
So I think we'll leave the audience questions for later, but Blake and Michael, thank you very much. Nice to see you guys. What I was most curious to hear about was that last slide you had, Blake, about the collaboration between APAP and ITS and what you guys are working on. And we heard earlier from Hyundai Innovations about the bot that they have around the UCI campus, and that was very interesting. And so I'm curious to know, and I know Steve Ritchie quite well. I'm wondering what's going on in terms of there was an actual case study, a campus study, I think, on sort of connected vehicles with the campus, and I don't know where that is, if that's going on or if that's happened, and then how HIMAC is then involved in that regard as well. What is the collaboration, if you don't mind, just in a short sum?
I'll cover the Living Laboratory connected vehicles quickly. So it's been a little bit stalled because of coronavirus, but the goal was to partner between UCI, ITS, APEP, the city of Irvine, potentially AT&T, and potentially a traffic signal controlling company that does like AI technology. The goal was to have Campus Road, which runs on one of the sides of campus, to implement the intersections so that safety messages could be fed from the vehicles to the infrastructure, to even pedestrians and bicyclists in the area for safety purposes. as well as for increasing the flow of the vehicles, that's buses and regular cars, through that intersection or that corridor.
Yeah, and the way that HiMac fits in, kind of as the slide showed, a little bit more of like the controlled laboratory, so not the full scale, you know, out on campus drive will be, you know, maybe we can recreate that on the computer, but bring those kind of technological, like, you know, the studies and everything that we find from there, bringing that out, as well as collaborating on kind of research for sensors and things. You know, the ITS, you do quite a bit with like LiDAR and combining that with video feeds and kind of seeing the transportational versus the more like infrastructure side of using these same kind of sensor technologies, as well as communications, the 5G that Jim talked about, and Wi-Fi and those sorts of things.
I think maybe the most short-term application area for overlapping interest in research is in eco-driving. So I talked about controlling those intersections. If they're passing information to all the vehicles that are approaching the intersection, you can do eco-driving. You can slow down the vehicles before the red light even hits, which is, you need some research on the powertrain, which ITS doesn't have a lot of expertise there, but APEP and HiMac do.
Okay, good. Well, thank you very much, gentlemen. It was a pleasure. Great hearing from you.
Yeah, thank you.
Good.
Yeah, so our final speaker is Evangelos Simotis. We're talking about transforming urban mobility. So Evangelos is a recognized expert in next generation mobility, artificial intelligence and big data, and corporate innovation. He's been working in Silicon Valley for 30 years as a venture investor, senior advisor to global corporations and governments, an entrepreneur, and sorry, I lost my train here. He invests also in early stage startups, develops enterprise software AI applications, and advises global corporations on AI. He's an author of a book, The Big Data Opportunity in Our Driverless Future, and recently published in Transportation Transformation. So Evangelos, thank you for being here today, and we look forward to your talk.
Well, thank you very much for the opportunity to address your audience. It's a tough act to follow given what we've already heard in this session, but I'll try to do my best to keep you entertained over the next 15, 20 minutes or so. So this is a wonderful time and interesting at the same time to be talking about urban mobility at a time when our own mobility is being severely curtailed because of the pandemic. It is wonderful because it is during this period of crisis when many disruptions occur and amazing opportunities emerge. And during a year when we are rethinking the environment, education, work, it is only fitting that we will try to reimagine transportation and begin its transformation. It is also interesting because when we talk about disruption, we tend to think about changes caused by either technology innovation or business model innovation. And this time we have the confluence of the two impacting the disruption and the transformation of transportation. So I wrote my new book based on a four-part thesis. The first part is that cities must take a leadership role in ushering new mobility and shaping its impact. And the best outcomes will come when cities, automakers, and mobility services companies collaborate. And I think as the speakers spoke earlier, there is a very great need for the collaboration of these three constituencies. However, because disruption involves transformation, each of these three constituencies will need to undertake some transformation as they come towards this collaboration. Now, if we are successful, and when we are successful, this collaboration will give rise to new forms of value and new value exchange models. And the book goes into a lot of detail about how these models are developed and what is the value that's being created. Next slide, please. But in order to understand where we need to go, it is important to consider where we are and where we're starting from. So today, in many parts of the world, we approach urban transportation as a collection of silos. Privately owned vehicles is one silo. Public transportation modalities represent a second silo. And as Mike said a minute ago, the various forms of mobility companies, whether it is for the movement of people or for the delivery of goods, represent a third silo that has been added to our urban mobility landscape. This approach impacts not only how we allocate resources to public transportation systems, but it also defines what type of services we offer, and for the automakers, what kind of vehicles they introduce to the market. The siloed approach also impacts the optimizations each constituency pursues. For example, in order to minimize the losses that many public transportation systems will have been facing and will now increase because of the pandemic, they may start curtailing their service and only offer it in high demand areas. This will leave certain parts of the city without public transportation, and that will lead to higher usage of privately owned vehicles, creating a vicious cycle in the process. So all of these independent decisions impact the overall urban mobility experience. Next slide, please. Our cities must approach new mobility as an integrated system, and that's a key point for the book. So an integrated system rather than a collection of silos. And we heard Mike saying that San Diego is one of the cities that is starting to think about kind of like an operating system for the city. So the providers of mobility, whether it is for passenger transportation or goods delivery, they need to operate under this system. Now, the city must lead the creation of this system. This is not only because it is the setting where we see all of this disruption, but actually because we cannot expect a company, be it an OEM or a mobility services company, to create a system that provides a city's entire population with mobility that is safe, affordable, convenient, and for the right experience for all. Experience tells us that companies will optimize around only a subset of these dimensions in order to benefit their shareholders, whose interests many times are antithetical to those of the city's entire population. Now, if a city is successful in achieving this goal, then we will start seeing a shift in the model that views a model that provides transportation through privately owned vehicle to one that views transportation and mobility as a utility. Next slide, please. Now, the ingredients that will have to be combined in the system include intelligent and highly instrumented transportation infrastructures, vehicles that are automated or autonomous, electrified, and connected, and innovative business models, many of which may not come from what is traditionally associated as transportation business models. This means, first, that in order to achieve the right combination of these ingredients, cities, automakers, and mobility services companies must form partnerships and collaborate. And second, technology and business models together and not separately will need to become the dimensions along which this transformation will need to occur in order to see this disruption in urban mobility. Let's see now where the state of each of these ingredients is. So next slide, please. Today's cities are characterized by transportation infrastructures that are vehicle-centric in terms of rather than being people-centric. These infrastructures are inadequately instrumented and they're poorly monetized. Cities are also behind in forming public-private partnerships, particularly with the new companies that are coming from new industries that can contribute significantly in new urban mobility. And finally, there is definitely a skill set gap, particularly in data utilization, in the exploitation of data using AI approaches, and in cybersecurity that cities have, which a lot of times adversely impact their ability to adopt new mobility. And my firm, we've been working with a number of cities, both here and abroad, and we're seeing this last point particularly as being one of critical inhibitor to their adoption of new mobility. Next slide, please. Similarly, OEMs in particular, but also other companies from the automotive ecosystem, they have been investing aggressively over the past 5-6 years in developing autonomous vehicles. Today, we're finding these vehicles still requiring significant technology improvements in order to expand their operating design domains and be useful within urban mobility. The second thing is that we need business models to monetize the right use cases. We've been spending a lot of time in developing the technology, but not enough time in developing and testing business models. And finally, we need to improve the consumer trust around the autonomous vehicles. And this consumer trust comes in 3 areas. First is in the usage of the vehicles. In other words, how consumers will be willing to utilize such vehicles on a daily basis rather than just as a curiosity. And what we're seeing is that on a geography by geography basis, the consumer tendencies tend to be significantly different. The second area is in understanding and taking the right protections against privacy. The new urban mobility that is based around these technologies will be both the generator and the consumer of massive amounts of data. This was the topic of my first book. And in doing so, we need to start worrying much more about privacy than we have before. And finally, we need to worry both about cybersecurity, but also physical security of both the passengers and the goods that are being transported in these under autonomous vehicles. Next slide, please. Now, while on-demand mobility services have been adopted globally, the companies in these sectors will need to start being embraced by cities as opposed to creating an antagonistical relationship with the cities. We're seeing this particularly outside the US. They need to strive to provide affordable, safe, and convenient transportation, something that has not happened today. I mean, we're seeing the usage of mobility services, and particularly the most popular of those being ride-hailing, is being focused on specific population segments as opposed to much broader within urban segments, and provide this service with a consistent user experience. Today, the experience is driven by the driver, particularly, again, as I said, with ride-hailing, as opposed to being uniform. And finally, we need to have consumer usage of these services that is consistent with the city's mobility goals. Next slide, please. Now, to be in the position to lead and catalyze collaboration, the 3 constituencies must transform. And in the case of cities, the transformation will need to enable them to determine how new mobility will address their transportation problems they face, be it pollution, congestion, space utilization, accidents. We're seeing again an uptick of accidents even during the pandemic period. How to best manage their resources and identify ways to fund the implementation of new mobility, which is a big issue right now, both here and abroad. Determine how to regulate without stifling innovation, and finally deciding what is their overall growth plan within this new urban mobility that we are all envisioning. Next slide, please. Now, the transformation that we're talking about and that will lead to this new urban mobility will take place in three phases. We're currently transitioning from the mobility services emergence phase that we've seen over the past decade to a new phase that we call the fleet formation phase. And during this phase, that cities will primarily collaborate with mobility services companies, and we'll see the emergence of the first combined fleets between these two constituencies. We will enter the true mobility as a utility phase by the end of this decade, by which time we expect highly automated and autonomous vehicles to have entered the urban mobility landscape and be used both for passenger movement as well as goods movement. And it is during this phase, this third phase, that we expect the automakers to start joining this collaboration between cities and mobility services providers. Next slide, please. In order to help the cities understand how transformations will need to take place and how willing they will be to undertake these transformations, we have developed this two-dimensional framework, and we use both business model innovation as well as technology innovation as the two dimensions along which cities can choose to transform. Now, as a result of transforming primarily along the technology dimensions, we see cities becoming smart infrastructure providers. And today, we're seeing over 100 cities globally starting down that path. As the result of transforming primarily along the business model dimension, we see cities becoming transportation coordinators, enabling them to improve the utilization and monetization of their transportation infrastructures. And finally, as a result of transforming along both dimensions, a city becomes a transportation orchestrator and is able to optimize the operation of all of its mobility resources. Next slide, please. Now, the privately owned vehicle value chains have remained largely unchanged. As these constituencies transform and start to collaborate to form integrated mobility systems, they will be joined by small and large companies from a variety of industries, such as telecommunications, utilities, entertainment, to create new value chains. Now, together, they will need to establish a set of processes, some of which will be completely new to mobility, and link them using a variety of data flows. And what's shown here is just a very small subset of the data flows that will be possible among these processes. This will create new value chains that will be implemented using a variety of models depending on how these constituencies are collaborating on a specific city-by-city basis. Next slide, please. These value chains will introduce new forms of value and will utilize new value exchange models. Loyalty and data will be two of the new forms of value that will be exchanged in these chains. In the case of loyalty, we will need to find, because of its importance going forward, we will need to find new ways of measuring it, and also new actions that will be able to impact it. And cities, for the first time, will need to start looking at loyalty and how to participate in these actions. Next slide, please. Very much like it has happened in the areas of online marketing and e-commerce, data will emerge as a key value creator in this new system. Data will come from a variety of sources here. It will come from the vehicle, the occupants of the vehicle, obviously the transportation infrastructures, the fleets that will be created, but also the supply chains for all of the components that come together in this new system. it will be broadly exchanged among these participants. Next slide, please. The transformations that will be undertaken by these three major constituencies and the degree by which they decide to collaborate on a city-by-city basis will determine how urban mobility will be implemented in each particular cities. And to this end, we're seeing three potential scenarios. Under the first scenario, we see a kind of coexistence of mobility services with privately owned vehicles and a continuously diminishing role of public transportation. Under the second scenario, we see a dominant role of multimodal public and private fleets, many of which will consist of autonomous vehicles, coexisting with privately owned vehicles. And then under a third scenario, which we see being implemented in a much more limited scope, frankly, we see a centrally orchestrated multimodal mobility offered exclusively as a service using advanced transportation networks with privately owned vehicles being eliminated from increasingly larger geofenced areas. Next slide, please. So while at other times such a mobility vision may have been considered as a pie in the sky, the pressures that cities are facing around the world due to the various challenges that we talked about makes the transportation of urban mobility an imperative. This transformation will require system thinking, it will require the breaking of existing silos and the application of new technologies and business models. And since we have started to reconsider our assumptions about work, education, climate, and we're starting to reimagine cities around people rather than around vehicles, it is only fitting that we will start in earnest to transform urban mobility. Thank you.
Great, thank you, Evangelos. Super interesting stuff. A couple of questions for you. The first one is, how can US cities learn from what's happening abroad, and again, particularly in Europe and Asia, around mobility and shaping this future around the urban landscape?
Yeah, I think it would be important for US cities to understand, and cities and metropolitan areas more broadly, to understand that there needs to be just a few coordinating bodies. I mean, what we have seen in the research that we've done, that my team and I have done for the book, is that particularly in the US, there is a very significant fragmentation among the various agencies that are participating in urban mobility, and that makes the coordination, the collaboration with the other constituencies, namely mobility services companies and automakers, much harder. I think we also need to start looking at urban mobility, as I said, as more of a utility that needs to be offered to every segment of the population, as opposed to something that can only be offered to a few that can afford it in terms of the better user experience. And I mean, that's something that both in Asia and in Europe, we're seeing very different attitudes that go back decades. These are not over the last year or two.
Yeah. A follow-up question to that is, given autonomous vehicles, what impact will they have on the mobility services offered in cities, and how do we maximize that impact?
It is actually, I would say, it is actually unfortunate that over the past few years, we have built autonomous vehicles around the robot taxi use case, which I think is actually one of the hardest use cases to achieve. And this is where most of the publicity of mobility of autonomous vehicles has come about. I think autonomous vehicles within urban environments can be utilized much more effectively around first and last mile transportation, particularly as it is provided by low speed autonomy as opposed to speed of traffic autonomy. as well as around the delivery of goods. And again, that delivery can be done using low-speed autonomous vehicles that are operating on streets or others that are operating on sidewalks. I think those kind of use cases will be much easier to digest for both cities and the public, and it will be much easier and less expensive to implement than the robotaxi case. You're already seeing a shift in the automakers from their level 4, level 5 autonomous vehicle programs more to lower levels of driving autonomy, level 2 plus, level 3, as it pertains to privately owned vehicles. And I think that will open up more the opportunity for, as I said, other vehicles using low-speed autonomy to be effectively implemented in urban landscapes.
Great, thank you. A lot to I like to digest, and I think one of the interesting themes that we all touched on was about really what is shaping the future, and I think that a lot of interesting sort of insights about how the considerations in there, and there are many in terms of when we're thinking about designing and building these future systems. Scott, any other questions you have or from the audience?
Yes. Can you hear me okay, by the way?
Yes.
Good. Yeah, I just had a quite a little bit of a glitch there on my side. Yeah. Question from an anonymous attendee here, Evangelos. Perhaps too much power for cities? Question mark. Given cities having 95% of power to build housing, their inability to make it happen. So how can it happen with the city for transportation?
Again, I think, I mean, again, when we were doing the research and ultimately wrote the book, I was not thinking just about U.S. cities. And I think what you're finding, I mean, here in the U.S., I think we're pushing way too much down to the city level, including issues around transportation. And I think that in order to have the right balance and to be able to execute successfully these transformations, other, both state level and federal level will need to be involved. And obviously, the city citizens will need to want to do that. I mean, this is not something that, particularly in the US, will come by fiat. It was interesting to me looking recently, the New York Times had an article about transforming certain parts of Manhattan and making them much more friendly to private micromobility as opposed to shared micromobility. And it was interesting reading the over 1,000 comments that were posted in a very short time to see how people were very diametrically opposed to even creating those type of measures that would have made Manhattan much more, as I said, easier to move around. And some of it had to do with where are we going to park our cars. Some of it had to do with, if you do this, how am I going to move around using my car? But again, here in the US, the private car ownership culture is so ingrained in our daily existence that seeing cities taking different measures around it make no sense. Whereas if you look at cities like Copenhagen or Paris or Berlin or Singapore, this type of changes come very naturally to the citizen, and you have a much more. In fact, one of the things that we have developed is what we call the transportation wallet, where we measure at the citizen level what is the use of mobility by modality, as well as what is the use of services in order to avoid personal trips. And it's fascinating to see what is the distribution in cities like Berlin, for example, versus in cities like Chicago. So again, we need to get down to that level of data analysis and obviously have the will of the citizens in order to be able to impact change like we have successfully done in other parts of the world.
Well, yeah, the will of the citizens. I mean, got to get some behavioral change, some mental changes, get our arms and minds around all of these things that are happening. Evangelos, I know that your time is limited. We have reached our 2 o'clock time. Trip, do you have any last thoughts or comments before I close us out here?
No, I mean, I really appreciate everyone's time and the opportunity to present here today. And I think, yeah, it was a great session.
Thank you.
It was a fantastic session, and thank you very much, Trip, for ably leading us through the day here. I have other questions that I've jotted down, and there are a couple of questions that looks like still in Q&A, but I think, given being sensitive to everyone's time, I think we're going to adjourn here. To all of our speakers today, and for all of our speakers for the last 3 days, thank you very much. This has been exceptional content-wise, and we would welcome all of your collaboration going forward as we continue in our working groups in mobility in all its shapes and sizes. We have lots going on, and future events that we'll be holding. We have an energy event coming up in December. We have a Capital Day coming up in mid-November, where we try to get money invested into early stage clean technology companies. So with that, and Robbie, do you have any final closing thoughts or comments for today?
No, thank you. Thanks to our sponsors. They did so much for us to enable this. And thanks to you, Scott, for partnering with me, and to Alan for doing all the stuff. So I think those things, I just wanted to say thank you.
Well, thank you for reminding me. Yes, Angie, Black and Veatch, and the LA Clean Tech Incubator, thank you for your sponsorship. Again, without you guys, we wouldn't be able to do these things. So to our sponsors, to Alan Ring behind the scenes there, fantastic job once again. And all of you have a wonderful remainder of the day and a great weekend, and we hope to see you all very soon. Thank you.